All right, let's go. Number 10, Big Crunch. For nearly a century, we have looked up at the night sky and found comfort in a specific assumption. The universe is expanding, and it will continue to do so forever. Since Edwin Hubble first observed that distant galaxies were accelerating away from us, cosmologists have mapped a universe stretching outward into an ever-cooling, ever-darkening void. But what if that expansion isn't an eternal law of physics, but a temporary phase? What if, right now, the cosmic pendulum is preparing to swing backward? This is the Big Crunch, a theory that suggests gravity is the ultimate victor in the cosmic tug-of-war against dark energy. If the universe holds enough mass, or if the repulsive force of dark energy eventually weakens and reverses, the expansion of the cosmos will grind to a halt. For a brief, terrifying geological epoch, the universe will hang suspended in a state of static equilibrium. And then, the retraction begins. Slowly at first, the distances between galaxy clusters will stop growing and begin to shrink. The redshift that currently stretches the light of distant galaxies into the infrared will shift to blue shift. The universe will be falling back in on itself. The consequences of this contraction defy human imagination. As the universe compresses, the cosmic microwave background, the residual heat of the Big Bang, will be compressed along with it. The background temperature of space, currently hovering just above absolute zero, will begin to rise. Millions of years before the actual end, the night sky will stop being dark. It will glow with the intense, concentrated radiation of a shrinking cosmos, becoming an unendurable oven. Stars will still be burning, but the space between them will be hotter than their surfaces. Galaxies will inevitably collide, not in the slow, graceful cosmic dances we observe today, but in violent, chaotic pileups driven by an inescapable gravitational mandate. Supermassive black holes at the centers of these galaxies will merge, creating gravitational behemoths of incomprehensible scale. Eventually, stars themselves will ignite and explode as the ambient temperature of the universe surpasses the heat of stellar cores. All matter, all energy, every monument of human history, and every alien world will be pulled into a single localized area. In the final moments, the structural integrity of atoms will fail. The universe will become a superheated plasma, and then a singularity. Everything that has ever existed will be crushed into a point infinitely small and infinitely dense. The horrifying existential takeaway of the Big Crunch is absolute erasure. There will be no ruins left behind for future observers. The very fabric of space and time will be unraveled and packed away into nothingness, leaving no trace that our reality, or anything in it, ever occurred. Number 9, Big Bounce. If the Big Crunch represents the ultimate, suffocating end to all things, the Big Bounce offers a continuation, but one that carries a deeply unsettling philosophical terror of its own. In standard cosmological models, a singularity implies an absolute end, a mathematical breakdown where physics simply stops. But according to loop quantum cosmology, a branch of physics attempting to reconcile quantum mechanics with general relativity, space itself is quantized. It is made of discrete, indivisible loops. Space cannot be compressed infinitely. It has a fundamental minimum size. When the contracting universe reaches this microscopic threshold, the immense gravitational energy cannot pack matter any tighter. Instead of collapsing into a point of zero volume, the sheer density creates a quantum repulsive force of unimaginable power. The universe rebounds. A new Big Bang occurs, instantly creating a brand new expanding cosmos from the ashes of the old one. At first glance, this might seem like a comforting thought. Reality doesn't end, it simply recycles. But the terror of the Big Bounce lies in the concept of eternal recurrence. If the universe bounces once, it has likely bounced before. Our reality, our 13.8 billion years of cosmic history, might not be a unique one-time event. It might simply be the current iteration of an infinite sequence of cosmic breaths, expanding, contracting, dying, and rebirthing. Are we the first universe? The billionth? The trillionth? And more importantly, does the universe reset exactly the same way every time? If the parameters of physics remain identical, then everything that has ever happened will happen again. You will live your exact life, make your exact mistakes, and feel your exact pain an infinite number of times, trapped in a deterministic cosmic loop from which there is no escape. Every war, every tragedy, every mass extinction is doomed to be replayed for eternity. Alternatively, if the laws of physics are scrambled with every bounce, then our specific reality is just a random, fleeting combination of variables. All human progress, all suffering, and all knowledge are entirely meaningless in the grand scheme. We are merely a temporary configuration of matter that will be erased and replaced by a completely alien universe with different physical laws, different elements, and different possibilities. The Big Bounce traps us in an existential nightmare. A reality where our existence is either a prison of eternal repetition or a totally insignificant, randomized blip in an endless cycle of cosmic destruction. Number 8. Vacuum collapse. In the realm of theoretical physics, there is an apocalypse scenario so sudden, so absolute, and so inescapable that it renders all other cosmic threats completely trivial. It is known as false vacuum decay. To understand this theory, you have to understand the Higgs field, an energy field that permeates the entire universe and gives all fundamental particles their mass. Like everything in the universe, the Higgs field seeks to rest at its lowest possible energy state, known as a true vacuum. Currently, our universe is stable, but quantum field theory suggests a terrifying possibility. The Higgs field might not be at its absolute lowest energy state. Instead, it might be resting in a false vacuum, a temporary valley on an energy graph that only appears stable because it hasn't yet found a way to drop into the deeper, true valley below it. It is like a boulder resting precariously on a ledge halfway down a mountain. It looks secure, but the slightest nudge could send it plummeting. In quantum mechanics, particles can occasionally tunnel through energy barriers without needing the energy to climb over them. At any moment, anywhere in the vast expanse of the cosmos, a tiny fluctuation could cause a microscopic region of the Higgs field to tunnel through the barrier and drop into the true vacuum state. This would trigger a catastrophic chain reaction. A bubble of true vacuum would instantly form and begin expanding outward in all directions at exactly the speed of light. Because it moves at the universal speed limit, there would be absolutely no warning. We could not see it coming through our telescopes. One instant, you are living your life. The next instant, you simply cease to exist. But it's what happens inside the bubble that is truly horrifying. The true vacuum operates under fundamentally different laws of physics. The energy of the vacuum dictates the masses of particles and the strength of the forces between them. As the bubble washes over Earth, the mass of electrons and protons would instantly change. The strong nuclear force that holds atoms together would shift. Chemistry, as we know it, would become mathematically impossible. In a fraction of a millisecond, every molecule in your body, every rock on Earth, every star in the sky would be violently disassembled. Matter would either collapse into itself or fly apart into a soup of unrecognizable subatomic particles. The universe would not just die. Its underlying operating system would be aggressively overwritten by alien physics. And because the universe is infinite, this bubble of doom could have already formed 1 billion years ago in a distant galaxy, silently racing toward us through the dark, ready to delete our reality before we can even process a single thought. Number 7. Entropy maximum. Not all apocalypses are violent. Some are painstakingly, agonizingly slow. Based on the fundamental laws of thermodynamics, the most widely accepted fate of our universe is the Big Freeze, or heat death. The second law of thermodynamics dictates that entropy, the measure of disorder and dissipated energy in a closed system, must always increase. Energy naturally spreads out from areas of high concentration to areas of low concentration until an absolute equilibrium is reached. Right now, the universe is full of localized hotspots. Stars, galaxies, and supernovas are concentrated pockets of energy surrounded by the cold vacuum of space. But this energy is finite, and it is being steadily spent. Over the next 100 trillion years, the last generation of stars will exhaust their nuclear fuel. The massive, brilliant blue and yellow stars will die first, followed eventually by the dim, long-lived red dwarfs. When the final star burns out, the universe will go pitch black. But reality won't be over yet. The cosmos will enter the degenerate era, dominated by stellar corpses, white dwarfs, neutron stars, and black holes. Over quadrillions of years, even these remnants will decay. White dwarfs will cool into dead, invisible black dwarfs. The gravitational dances of dead planets and dead stars will eventually send them crashing into supermassive black holes, or flinging them out into the expanding frozen void. Then comes the black hole era. The only objects of significance left in the universe will be black holes, drifting through an infinite expanse of absolute darkness. But even these gravitational titans are not immortal. Thanks to Stephen Hawking, we know that black holes emit a microscopic stream of radiation. Over timescales that break the human mind, a 1 followed by 100 zeros of years, even the most massive black holes will slowly evaporate, exploding in a final, pathetic flash of light that no eyes will be left to see. Finally, the universe will reach maximum entropy. The dark era begins. The last remaining matter, stray protons and electrons, will likely decay into photons and light subatomic particles. These particles will be stretched by the accelerating expansion of space until their wavelengths are larger than the observable universe itself. The temperature of reality will drop to absolute zero. No energy can be exchanged, no work can be done, no thoughts can be processed. Time itself loses all meaning, because without change, time does not exist. The terror of heat death is not destruction, but the profound, eternal silence. A reality reduced to an infinitely large, infinitely dark, and infinitely cold tomb, persisting in a state of absolute nothingness forever. Number 6. Cosmic phase transition. We tend to view the vacuum of space as an empty stage where the actors, stars, planets, and humans play out their roles. But space-time is not a passive void. It is a physical fabric with its own distinct properties, structures, and phases. Just as liquid water can transition into solid ice or gaseous steam depending on ambient conditions, the fabric of the universe itself is capable of undergoing a cosmic phase transition. In the immediate fraction of a second after the Big Bang, the universe underwent several rapid phase transitions as it cooled. These shifts caused the fundamental forces of nature, which were originally unified into a single superforce, to separate into gravity, electromagnetism, and the strong and weak nuclear forces. It was during these transitions that the basic architecture of our reality was forged. But there is no fundamental physical law that dictates our current configuration is the final one. The universe is still expanding, still cooling, and still evolving. What if the ambient temperature or energy density of the cosmos crosses a hidden, critical threshold? If a new cosmic phase transition were to occur, the fabric of space-time would instantly shift states. The fundamental constants that govern reality would warp. The speed of light could suddenly slow to a crawl, or accelerate wildly. Gravity might become a repulsive force, pushing matter apart, or it might multiply in strength, instantly crushing planetary systems into dust. Unlike false vacuum decay, which expands from a single point, a cosmic phase transition could theoretically occur everywhere simultaneously, driven by the global cooling of the universe. The unsettling reality of this theory is that the universe wouldn't necessarily end in a traditional sense. The stage would remain, but the environment would become instantly and totally hostile to the matter that currently inhabits it. Carbon-based biology relies on a delicate balance of electromagnetism and the strong nuclear force. If these forces shift by even a fraction of a percent, the complex molecules that make up DNA would repel each other and dissolve. Humanity, Earth, and every star we can see would not explode. We would simply melt into the new background physics of the cosmos. We would be violently reconfigured into exotic new forms of matter that are compatible with the new phase of space-time. Reality would continue, but we would be fundamentally locked out of it, erased by a sudden, arbitrary change in the universe's operating code. Number 5. Dimensional collapse. Our daily existence is heavily reliant on the unquestioned stability of 3 spatial dimensions: up and down, left and right, forward and backward, plus the dimension of time. Everything we build, everything we are, requires this exact geometric framework. But in advanced theoretical physics, particularly within string theory and M theory, the universe actually contains up to 11 dimensions. According to these mathematical models, the extra dimensions didn't vanish after the Big Bang. They simply curled up or compactified into microscopic, unimaginably complex shapes called Calabi-Yau manifolds. They exist all around us, but they are so small that we cannot perceive them or interact with them. Our 3D space is just one specific configuration, an unfolding of dimensions that happen to stabilize during the universe's birth. But what guarantees this stability? A dimensional collapse proposes that the structural integrity of our macroscopic dimensions is temporary. At some point, the intense gravitational stresses of the universe, or a dark energy-driven tear in the cosmic fabric, could cause the dimensional architecture to destabilize. The consequences would be a geometric nightmare. Imagine if one of our extended spatial dimensions suddenly began to curl up, compactifying back down to a microscopic scale. Reality as we know it would be crushed flat. Planets, stars, and human bodies would be forcibly reduced to two-dimensional planes. The biological mechanisms of a 3D organism cannot function in 2D space. Blood couldn't pump, neurons couldn't fire, and molecular bonds would snap as the geometry of atoms is shredded. Conversely, what if one of the hidden, microscopic dimensions suddenly unspooled and expanded into the macroscopic world? Our three-dimensional reality would instantly be dragged into a four-dimensional space. The internal structures of our bodies would become completely exposed to this new dimension. The gravity holding our planet together would bleed out into the new spatial axis, causing orbits to instantly destabilize and solid matter to fall apart. The horror of dimensional collapse is that it bypasses standard destruction entirely. It doesn't rely on heat, cold, or explosions. It attacks the very concept of shape and volume. Reality wouldn't just be destroyed, it would be folded, squashed, and stretched into a realm of pure mathematical abstraction, rendering existence as we understand it completely impossible. Number 4. Information Erasure Universe. In the rapidly evolving field of information theory, some physicists have begun to argue that the universe is not fundamentally made of matter or energy, but of information. Every particle has a spin, a charge, and a position, data points that are constantly interacting, updating, and computing the state of reality. From this perspective, the entire cosmos is essentially a gargantuan quantum computer, processing the program of existence in real time. But computers have limitations. They require energy to process data, and they have finite storage capacities. This brings us to a terrifying cosmological application of Landauer's principle, a physical law stating that the erasure of information requires the dissipation of energy. If the universe is a finite informational system, it must have a memory limit. For 13.8 billion years, it has been accumulating data, the trajectories of every photon, the outcomes of every quantum entanglement, the memories encoded in every human brain. What happens when the cosmic hard drive is full? To continue functioning, to allow time to move forward and new events to occur, the universe might be forced to trigger a localized or global reset. It would have to delete data to free up processing space. This is the information erasure universe. The onset of this reality-ending event would be surreal and deeply disturbing. It wouldn't look like a physical catastrophe. Instead, the past would begin to literally disappear. Causality would break down. The historical data points necessary for an object to exist would be overwritten. You might reach for a cup on your desk, only to find the cup gone, along with your memory of ever owning it, and the physical record of the factory that manufactured it. As the universal garbage collection algorithm ramps up, entire galaxies, historical epochs, and fundamental physical laws would be selected for deletion. The data that constitutes your consciousness, your identity, and your loved ones would simply be zeroed out. The true horror of information erasure is the realization that reality is just a fragile data set. We wouldn't die. We would simply be formatted. There would be no afterlife, no legacy, and no record that humanity ever existed, because the very concept of the past would be physically scrubbed from the universe's memory banks to make room for a new, arbitrary computation. Number 3. Simulation shutdown. In 2003, philosopher Nick Bostrom formalized an argument that has since haunted astrophysicists and tech billionaires alike: the simulation hypothesis. The logic is chillingly airtight. If any advanced civilization ever reaches the point where they can create realistic, conscious simulations of reality, and if they have an interest in running multiple simulations for research or entertainment, then simulated realities will vastly outnumber the single base reality. Therefore, statistically, it is almost a mathematical certainty that we are living inside a computer simulation. If we accept this premise, we must confront the darkest vulnerability of our existence. We are not bound by the natural laws of physics, but by the whims, resources, and attention spans of our creators. And every simulation, no matter how complex, eventually ends. This is the simulation shutdown. Why would they pull the plug? Perhaps the civilization running us is facing an energy crisis in base reality and needs to conserve computing power. Perhaps the research project we were generated for has reached its conclusion. Or, most terrifyingly, perhaps humanity is on the verge of discovering the boundaries of the code, building artificial superintelligence, or probing too deeply into quantum mechanics, and the creators decide to terminate the program before we breach our digital containment. The end wouldn't come via asteroids or supernovas. It would come as a degradation of reality itself. We might start seeing rendering errors in the night sky. Stars suddenly disappearing from our telescopes without physical explanation. Macroscopic objects phasing in and out of existence. The speed of light might fluctuate as the servers struggle to process the data load of our expanding technological civilization. And then, the shutdown sequence initiates. Unlike a physical death, which happens within the flow of time, a simulation shutdown would annihilate time itself. The moment the program terminates, the universe doesn't burn or freeze. It simply goes black. Every thought, every feeling, every piece of art, and every war fought over the history of Earth is immediately flushed from the RAM of a higher dimensional server. The ultimate existential horror of the simulation shutdown is the absolute insignificance it assigns to us. We were never real. Our struggles were just algorithms running in a void. We are completely helpless, existing entirely at the mercy of unfathomable beings whose fingers are hovering over the delete key, ready to plunge our universe back into the digital nothingness from which it was artificially summoned. Number 2. Quantum collapse of reality. The strangest and most unnerving branch of science is quantum mechanics. At the subatomic level, particles do not exist in fixed, definite states. Instead, they exist in a superposition of all possible states simultaneously, defined by a mathematical probability wave called a wave function. It is only when an observer measures or interacts with the particle that this wave function collapses, forcing the particle to choose a single, definite reality. For decades, physicists have grappled with the implications of this. If the building blocks of reality only lock into place when interacted with, what about the universe as a whole? Theoretical physics posits the existence of a universal wave function, a gargantuan, complex probability wave that encompasses the entire cosmos. Currently, the universe is a dynamic, evolving system. Time flows, particles entangle, and matter moves because the universal wave function is in a constant rolling state of localized collapses and superpositions. It is the engine of change. But what if this meta wave function faces a terminal event? This is the quantum collapse of reality. Imagine an event, perhaps a specific configuration of matter, a threshold of universal observation, or a macroscopic quantum entanglement that triggers a simultaneous, universal collapse of the entire cosmic wave function. The probability wave of the universe is forced to instantly lock into a single definitive state. The result is unimaginable paralysis. The universe doesn't explode. It freezes on a fundamental, subatomic level. Because the wave function has completely collapsed, the quantum uncertainty that allows particles to move, bond, and transition is eliminated. Without quantum transitions, chemical reactions cannot occur. Electrons cannot orbit nuclei. Time itself would stop. Time is nothing more than the measurement of change, and in a fully collapsed, static universe, change is mathematically forbidden. The entire cosmos would be instantly frozen in a single infinite quantum snapshot. If this happened right now, you would not realize it. The electrical signals in your brain would freeze mid-thought. A bird in the sky would be locked in mid-flight forever. A dying star would be paused exactly at the moment of detonation. Reality becomes a paralyzed sculpture of itself, trapped in an eternal, dead moment. The universe would persist forever, but nothing would ever happen again. Number 1. End of mathematics. We seek to understand the universe through telescopes and particle colliders, but the ultimate language of reality is not light or matter. It is mathematics. Physics is simply applied mathematics. Everything in the cosmos, from the orbits of planets to the vibration of quarks, obeys strict, underlying logical rules. We assume this mathematical foundation is absolute, eternal, and perfectly consistent. But what if it isn't? In 1931, mathematician Kurt Gödel published his incompleteness theorems, sending shockwaves through the scientific world. Gödel proved mathematically that any sufficiently complex logical system will inevitably contain statements that are true but impossible to prove. And worse, it might contain hidden, fatal contradictions. For decades, this was viewed as a quirk of human arithmetic. But what if Gödel's theorems apply to the physical universe itself? This theory, the end of mathematics, proposes that the fundamental logic operating our reality contains an inherent, inescapable paradox. For 13.8 billion years, the universe has been executing its mathematical code, running physical processes like a massive equation. But as the universe expands, ages, and generates increasingly complex structures, it pushes the boundaries of its own operating logic. What happens when the universe finally attempts to compute that hidden contradiction? The resulting catastrophe would be the most terrifying end imaginable, because it attacks the concept of meaning itself. It wouldn't be a physical explosion. It would be the dissolution of cause and effect. The mathematical rules that bind reality together would decouple. Gravity might suddenly cause objects to fall upward. The concept of distance would break, making an object simultaneously millions of light years away and right next to you. 1 plus 1 would no longer equal 2. The very concept of quantity would unravel. Energy conservation would fail, allowing infinite heat to spawn from nothing, or entire galaxies to vanish without a trace. As the logical inconsistency cascades through reality, space and time would lose their structural integrity. Your own thoughts would become impossible as the electrical logic of your brain dissolves into paradox. The universe would not return to a void of nothingness, because even nothingness requires a logical definition. Instead, reality would plunge into absolute, incomprehensible chaos, a state where rules, existence, and non-existence fluctuate randomly, forever. It is an end that breaks not just our bodies, but the very possibility of understanding what killed us. If you want to see more videos like this, click the video on screen now and make sure to subscribe.